thank you, everybody, first of all, and appreciate your patience with me. And I happen to be also not at home and currently running, doing this presentation from remote. It's actually near my house, but I'm actually at another conference, which is in Chicago. So I'm not at home. But thank you again. Just appreciate your patience, a bit of a mix up in here. So I'm going to try to go a little bit faster. We only have like 30, or right now it's like 32 minutes. So first of all, thank you. The title of my talk today is on event streaming for the best of all worlds. And the time when I actually did this proposal, it was actually before the time I decided to also updated my title to say event streaming essentially for, using Apache Pulsar or cloud native event streaming. So this conference, right, it's very much about Kubernetes, about the cloud, the infrastructure, with the cloud. And so this actually is what this talk is about, event streaming, but for the cloud native environment. So thank you again for coming. And before I start, if you like to have an access to this slide deck. So what you're seeing now is the bit.ly short link that you can get to it or scan the QR code. So I'll leave this on for 20 seconds if you want to quickly scan it or copy down or take a picture, screenshot. And then even if you miss it, don't worry about it because I will be sharing this link with Cesar and Isabel with the J4K organization. So, okay, so with that, let me move forward. First of all, just a bit of an introduction. I am Mary Grygleski. I'm a senior developer advocate at DataStax with their streaming team. So streaming is new to DataStax. And if you are familiar with NoSQL, I bet you have heard of Cassandra. So that's how DataStax started. It's more about, open source, NoSQL, Cassandra. Now it kind of has the managed cloud platform called Astra. And so it's very much a database as a service company, big data, all those things. And then it's just like a year and a half or so ago, company decided to also adopt the streaming capability and has since adopted another Apache project, a great project called Apache Pulsar. That's what I'm going to be talking about. So I'm with that unit and we're pretty much kind of all together, engineers, product people, the marketing, everything, we're kind of together, but we work with the larger company with Cassandra too. So, and previously I was with IBM with their Java developer advocacy team. Maybe if you came to J4K in the past, I spoke here before, and at the time I was with IBM, Java, open source, Eclipse projects too, such as microprofile, open liberty, that type. So. And then I'm based in Chicago. I'm also a Java champion and president and also board member of the Chicago Java Users Group. I'm an active community contributor. So I actually was a developer too for over 20 years before becoming an advocate. And I really love it. I just love the outreach to talk to folks. And because of my experience in the field, sometimes, we joke about things and I totally understand it. I think there's so much fun in this field. At the same time, there's also things that we all know is not ideal, right? But we try to make it fun. And that's what I love doing my job now. I think we all should find fun in what we do every day and learn as we go along too and improve our skills. So this is just a slide deck about me quickly kind of describing, right, that all these things is more pictorially describing myself, plus the link as to how you can get a hold of me, all these things. And I will be sharing that again towards the end of this presentation, even if you have missed it now. Okay, so let me quickly start, right? So let's then try to kind of everybody come together on the same page. I want to talk about event streaming specifically too, also for the cloud infrastructural environment. So I want to talk about the many facets of computing events. I think it's confusing enough. Even before, I worked actually on reactive systems and I did talks actually at J4K talking about reactive things. And as such too, I feel reactive is just another label of describing something very fast, very responsive, right? And it's really essentially, it's about events. And so if you talk about events, it's what we are kind of working with, whether they are reactive or not, it's just another name for it. So, okay, so some kind of terminology, and then I'll go into talking about why do we need event streaming, right? What can it do to kind of improve your systems essentially? And then I'll introduce to you Apache Pulsar and its dependency on Apache Zookeeper and Apache Bookkeeper. These are dependencies that Pulsar has. And then I will highlight a couple of developer features and also essentially why Pulsar, right? It's really is poised to become, I believe it's in the cloud, in this cloud native world, it is the de facto, it should become the de facto event streaming platform. Okay, let me start. So the many facets of computing events. First of all, let's look at, what is actually an event, right? Kind of generically speaking. I find that, sometimes let's kind of try to understand. We're doing too many things. Sometimes we don't stop and pause and think what it is that we're working with. So, but let's get down to the basic. It's like, things. We get down looking at things. Everything starts with an atom, right? So in this case, okay, we're dealing with event processing, event streaming, event handling. But essentially, let's see what this atom, this event is. So I look up, do some kind of, due diligence, looking up Merriam-Webster.com, the dictionary. Essentially, it just means something that just happens, right? Generically speaking, it doesn't have to be computers. It can be a musical event, a sporting event, right? These are occurrence. These are things that just happens. But of course, we're dealing with computers. We're all developer technology people. So we are more interested in the definition that's kind of postulated by the theory of relativity. It's essentially, right, if you kind of look at it, it's very abstract for event, but if you want to really look at it right from a mathematical scientific way, it's essentially dealing with the three dimensions of place, right? The coordinates of place, X, Y, Z coordinate. And the amazing, the fun thing, I think, right, in doing computing events is basically you bring in the fourth dimension, which is time. So you can have things happening in your coordinates, right? And it changes at every point in time, or it can, right? Even if, let's say, your event, the data can stay the same. Okay, so at a certain time, it might still stay the same, but in reality, though, we know that events, things, right, keeps moving. Even if, you move into the next second, that point in time will change. The data will change, may change, I should say, right? Most of the time it should change. We just keep kind of moving kind of thing. So essentially, that's what we're dealing with, computing events. And now let's take a look then at event streaming and processing. Essentially, that means just it really means is the practice of taking action on a series of all of these data points, right? That these points originate from a system. The system will continuously create data. Somehow there's a source that continuously produces data. So the event is referring to each data point in the system, and the stream is really an ongoing delivery of those events. And a series of all of these events together, essentially, that's what we're dealing with, streaming data or data streams. Now, there's a point I like to make too, because I got asked by someone at a previous conference was saying that, can I do audio and video streaming, right? Movie streaming. Okay, that's actually a very good question, because I thought we could, but actually, the thing is too, is that I did a bit of research and I realized that audio and video type of data, on the rendering side, it actually does require a lot more coordination. In fact, the rendering side requires more synchronous processing. So in some sense too, this Apache Pulsar isn't really catered for doing audio and visual kind of movie kind of streaming, media streaming. This here we're talking about are really about data, right? Data that's kind of mostly for your computing needs, right? Non-audiovisual type of data. So a series of events then essentially what kind of is kind of composed, data streams of data are essentially composed of a series of events. So that's what we talk about. Okay, so enough of this basic. Let's move on a little bit. Now, the thing is, when we kind of talk about computers, there are just so many aspects of it, right? Each aspect is already a study in itself. But let's kind of move on to this, right? About streaming, event processing. There's this term that's called like complex event processing. This, in fact, when I went to Kafka's site, I found that they have a good explanation for it too. Or if you search on the internet, you can also find explanation. And I'm finding this to be quite satisfying in terms of the fact that when we deal with event processing, right, you can have the, dealing with the ingestion side of things. And after you take the data, you need to transform it, the messages, right? And then somehow you need to output it to somewhere, to a sink, for example. That kind of very complex too. And not only that, ingestion is one aspect of it. The thing is, you want to be able to ingest it, capture the data, store it, somehow store it, right? And then analyze it. And that's what gives you the value of all your activities. Because, for example, you are doing fraud detection system. They will be, you have in your bank account, I'm sure these days, right? They have kind of any kind of suspicious activities kind of monitoring of your bank accounts, right? It's constantly analyzing data. So if it notices something that's out of the ordinary, it will alert you, right? So that's the whole goal. That will be like one kind of use case that you can actually do need to leverage on complex event processing. And that's kind of prime example that we cannot use any other system other than the fact that it needs to be real time, it needs to be instant, it needs to be able to respond to any kind of events that's unusual. Okay, so fraud detection is one such example. You can also have recommendation engine, right? I'm sure you are familiar with online shopping. So those things too, as you notice, right? If you go to a site, there's always some kind of advertisement box out on your screen suggesting, recommending you to buy something else, right? Or some other brands of things. So those are also kind of prime example of systems that can leverage on event streaming. And those are called complex event streaming. Is analyzing what you're buying, what you've clicked on, and it immediately kind of analyze, right? And realize that, okay, let me also make recommendation for you for other products in the same category, things like that. So, okay, so that's kind of a quick thing explaining complex events processing. So now then, let's take a look then back a bit more basic about messaging. So I would think, messaging really deal more with the mechanical aspect of the exchange of data between like multiple entities. Okay, so there are differences, right? There are event-driven and also message-driven messaging. So they are not the same. Event-driven is essentially talking about a one-to-many type of relationship. There's sender on one side, it emits the messages, right? When data is here, it will send the data out. And then it's up to those who are interested. The interested subscribers will need to subscribe to the messages in order to be able to receive it. So in some sense to event-driven is kind of, we are attributed it to sort of like, pub/sub type of processing, even though not necessarily, well, although I should say pub/sub event-driven, they are kind of in the same kind of boat, essentially, right? Okay, then there's also message-driven. Oh, before I forget, event-driven essentially too is that your sender, and that's why it makes it more scalable, is that every time, right, if we need to send a message, let's say not dealing with computer messages, we're sending a letter. What do we need, right? We need to address that letter, who is going to receive it. Now, as you can see, back to the event-driven definition is that it doesn't require the producer to know who the messages, who we should send the messages to. It's basically up to the subscriber to subscribe to it. So that's kind of one difference is there's no need to know what the address of the recipient. Whereas message driven is that sender and receiver is like point to point. They have to know, essentially, especially in cases in which you're doing bidirectional messaging, then you will have to know each other address too. So that's kind of one major differences in this, in kind of differentiating the different types of messaging. Now, let's take a look then at event approach versus batch processing. So the thing is, before doing things in event-driven way, actually, we are all, already doing some events one way or the other. However, it's not for all cases. So for example, like batch processing, I'm sure that if you work for big companies, especially, or not big or small, you also have processes that would be collecting some changes, right, to your database during the day, and then it gets batched up, right, and then it will then be sent to the server for processing. So that's kind of batch processing. So as you can see, event is actually deal more with real-time processing. It's very dynamic data. We immediately take the data as it changes, right, comes into the system. We do something about it, analyze or save it into storage, things like that. So that's more event-driven like thing. But the thing is, sometimes, right, for example, your employee information system, you are updating your employee record in your company, though those kind of information you can wait, it's not very urgent. So you can kind of use a batch processing type of approach for it. So again, this is just to kind of give you, some background information about events, what is it that's kind of special about it, right? This kind of information. And now, just introduce you then to the event messaging semantics and patterns. So essentially, there are two ways, right? The goal of doing messaging is that you want to decouple the sender and the receiver. And the benefits of such is that you can increase the throughput. Think of the fact that your sender doesn't need to know the address, right? And you can add more, kind of receiver on the other end. And basically, pops up is the architectural pattern, design pattern we can use. Bear in mind that this is just a design pattern. It doesn't kind of tell you how to do things. So it's up to vendors or library implementers to implement this concept, right? The pops up approach. The thing is with pops up is that it always on having a middleman or middle person, or I kind of liken it to a post office. You need to send your messages. You don't send it yourself. You basically kind of bring it to the post office. Now, in this case, you can say, well, I'm a marketer, right? I want to market my products. I don't know who will receive it, but let me give it to the postmaster and then tell it, okay, this is just maybe like, company ABC catalog or something. I have a label it, calling it a topic. And so in this particular case, a pops up way is that whoever is interested in your messages, they will subscribe to that topic called ABC messages, something, right? An ABC topic. And so whenever the publisher produces the messages and it labels it ABC messages, give it to the broker will then look at, well, who are the subscribers? If you're subscribed to it, I'll deliver the messages from ABC topic to you, kind of like that. So that's essentially pops up, and it's also kind of what we describe as streaming, right? The mechanism behind the scenes helping to do streaming. You can actually have data coming in, and you can have increased number of data. You can actually have multiple brokers. You can have topics too, and all these things. So the nice thing about it, it decouples and also helps you to scale really easily. Another way of doing messaging too is that now, not unlike pops up one-to-many, this one is a one-to-one, point-to-point communication. It's called message queuing. It's much like, especially if you're Java, here is a conference about Java. So Java developers, we've worked with data structures, we work with queue. So the thing is with queue is that message queue is that basically you only have one consumer for each messages, right? So the idea is also like, essentially too, you decouple, right, the sender and the receiver. So then you also then in this case kind of make your you buffer up all of your work. For example, you decouple it. It basically makes the processing much faster in this case too. So examples too, it could be, you can actually be using it for some kind of company kind of notification systems, things like that. But then again, message queues are that, the messages, once they kind of gets delivered, it will be removed off the queue, versus like pops up kind of implementation. For example, like Pulsar, we actually have, the bookkeeper, for example, to keep these messages too in the bookkeeper kind of storage too. So that's kind of like the differences. So in a nutshell. So now then let's take a look. Event streaming, right? It's really a step beyond just the messaging aspect. And let's take a look. What is driving this change? Why is it that event streaming becoming the thing of today's world? So essentially, there's three main kind of primary kind of big usages of goals of, why you want to use event streaming. Essentially, it allows you to do things in a very real-time, instantaneous kind of fashion, right? So that has a lot of benefits. Let's say if you are developing some system for your customers to interact, maybe to buy things, to like purchase order system, things like that, right? Everything are done in real time. They don't need to wait. I browse through the catalog, I pick something I want, immediately you put into, you submit your order. It should all be there. It takes care of all of the payment in the background. So that's kind of a very good thing, right? Because we live in a fast-paced world. It's a little bit crazy, but the thing is, it kind of helps with delivery of your messages in real time. Now, the second thing is that if you think deeper too, you can use this approach to essentially, build out what is called like data pipelines. What are pipelines? Pipelines are dealing with data coming in. You have distinctly kind of separate out into data source, and then the source coming in, you ingest the data, you do some sort of transformation, and after that data is transformed and it outputs it to a sink, right? Some kind of output. So that's kind of data pipes, and that helps you. For example, example in here is to build your artificial intelligence or machine learning data pipeline. As we know, right, AI and machine learning, they are constantly, especially if you use some sort of like reinforcement kind of learning, because you don't know what the data model is, but you want to rely on data in real time, and immediately you analyze it, and then essentially to have your algorithms to build out your model at that point in time and do the deployment. So as you can see, it's a very quick turnaround. So you can consider using event streaming type of system to help you ingest huge amounts of data. I'm not just talking about, kind of megabytes, right, or something, right, or terabytes. These are petabytes, and it's really huge amounts of data, right? So you can consider using event-driven system to help you to build data pipelines. And then another thing is scalability aspect, right? As I talk about, it will be really, really fast. You need to scale it up and down. It becomes much easier if you're using a pub-sub type of approach or using a queuing. So then you don't tie together the sender and the receiver. They are not tightly coupled. So those are the reasons. Okay, this is just a quick kind of description, kind of summarizing. It helps you to watch for the events with the system or the application, essentially to help the subscribing client, the receiving side can subscribe to topics that are only of certain interest to them. You don't want to receive everything. You don't want to receive things that you don't need. And then it helps too, you can make decisions in real time, the dynamic nature of doing like workflow, data flow in real time, not after the event, right? It helps you to ingest high frequency of messages and enable it to respond back, right, with very low latency, right? So for example, like trading firms, for example, you need to have immediately market maker, right, sending in some data, you want to immediately do something and then respond back, all that kind of stuff, right? Those are just examples. Now, let me again also take a look as to like streaming versus not streaming. So as you can see, let's start with the bottom one. If you're not using streaming, what's the traditional way of doing things is that we ingest the data. Usually too, we ingest the data, we have to store it. So the traditional way is to persist the data into database, right? Maybe a relational database, that type of stuff. And then from there, you need to do another step of selecting, all your SQL data. For example, if you're using SQL database, you need to do all the selection of these things. But as you can see, anytime you deal with disk IO, right, with your persisting data, it will incur a cost of time, even though you think, okay, well, is how many 1 nano, 0.001 nanosecond. But if you're dealing with huge amounts of data, it does matter. So as you can see, not streaming is essentially you have this database kind of storage layer in between that kind of can slow things down. Now, using streaming, then it can be different because you actually, as data comes in, you can process it right away in memory as well. And then when you're ready, then you write it to a sink, right, or something. And then later, you can also kind of select the data back and read them too. So that's kind of advantages. You can see there are fewer steps in between. It ensures like faster type of response. Now, let me introduce you Apache Pulsar. What is Pulsar? It is an open source Apache Foundation, software foundation project. It was originally created by Yahoo in the early 2010s. They realized at that time too, dealing with all of the Yahoo services, finances, you name it, right? All those Yahoo services that you can see, dealing with huge amounts of data. So, and also they also wanted to make sure the data gets replicated correctly, all of these things, right? There are lots of things going on behind the scenes too when you were dealing with messaging. So Yahoo decided, well, it's kind of not able to deal with all the cloud stuff, and it's too much work to have to do our own replication, and kind of you want to scale it. Oh, it's what a nightmare. You need to write all these things to kind of take care of the topics being able to get split evenly, into your new node and things like that. So they started developing and tinkering, right, with Pulsar, and that's what Pulsar is today, is from that time. They did actually donated to ASF in 2016 and quickly became a top level project because people are recognizing its cloud native kind of capability. And it's very much a cloud native design. Cloud native is in its DNA, I call it, all cluster based. And also it has a multi-tenancy. So you can actually, all your data, you can already kind of leverage on Pulsar's capability of dividing them up, kind of for better management, right? Sometimes in your organization, you have different teams that are managing data separately. So there's kind of capability to handle multi-tenancy. And also too, the nice thing about this is that the client APIs are simpler too. Now there are people too asking me, because the thing is too, you can use Java messaging service, right? JMS is an older protocol. It's a Java specific protocol. If you write clients to it, there are topics, there are queues, you need to do it in Java. But let's say in Pulsar, it's so flexible. The broker itself is written in Java, but you can actually use different types of client languages as long as they are supported. Right now, officially it's Java, and then .NET too. If you are not a Java person, you can use .NET. If you're familiar with that, use .NET client, use Python, use Go, and some community contribution, let's say to Scala even. So. And the thing too, with Pulsar is that it separates out the compute and the storage. What is it? What does it mean? It means that, your broker is handling all of these messages flowing in, all of these things. And it's basically too, the broker will handle all of these messaging, sending, receiving, and it also coordinate with the storage part because Pulsar delegates it to Apache Bookkeeper. Yes, it is a separate process, but think of it this way. Apache Bookkeeper is a very efficient kind of, as the name implies, so it's a bookkeeper. It manages all of these records. It uses an append-only type of log messaging mechanism. So as you can see, it's much faster. Every time new records come in, it goes to the end, right? So no need to kind of search and seek all of these things. So it's very efficient. So the thing is, Pulsar knows well enough that I'm not going to deal with those log messages. I'll hire somebody, well, kind of like us, right? We have a huge house. Do we want to do the cleaning ourselves? We hire maybe like cleaning service to come in and do all that stuff, right? Well, that's kind of a crude way of describing, but that's essentially what it is. Pulsar says, I'm going to deal with more of the compute side. I'll have Bookkeeper manage all of the log messages, the storages, the replay, kind of all these things. So. Okay, and then another thing about Pulsar is the message delivery is guaranteed. So you have to be kind of rest assured, right? These are like, different message mode of delivery that you can set to. So it's basically the broker is there to guarantee that even if the network goes down, don't worry about it. And when it comes back up, the broker will guarantee will be doing the work and help and deliver the messages that you asked. And then another feature of that Pulsar is actually a serverless functions framework that allows you to write functional code, right? Small bits and bytes of code to transform your messages as the messages travel through your data pipeline. So, so without you having to use another third-party languages. So this kind of, you can compare it with something like AWS, like Lambdas, or and Google Functions and Azure Functions. It's kind of in the same spirit. Also, Pulsar has a lightweight serverless functions framework. And then there's also this feature called tiered storage offloads. So as we can see, right, dealing with all kinds of messages, there are a lot of them. So sometimes too, messages will become, cold because then maybe it's done processing, but the client hasn't acknowledged it. So it's still hanging around, in storage. So Pulsar knows well enough to manage it and move it off to cold storage from the hot, warm area. So it allows the hot, warm storage to deal with more urgent messages. Okay, so again, this is just a quick thing summarizing what is Apache Pulsar. Is a unified distributed messaging and streaming platform, right? So very cloud native ready, all these things. So let me kind of quickly go over who else is using Pulsar just to share with you. These are the different companies that are already using it, and Splunk, right? Yahoo, Verizon, for example, and a couple of Chinese information big companies as well. Pulsar is different. So let me really quickly summarize it for you. But these are, I already talked about, it has producer, consumer, broker, and then the bookkeeper it relies on. Also, too, it does use a Zookeeper to help with managing metadata and handling, coordination of tasks between different Pulsar clusters, all of these things. Now, also, too, Pulsar has a tiered architecture design. So the nice thing about this is that if you need to scale it, it actually takes care of rebalancing all of your topics, right? As I mentioned earlier, too, you can have multiple brokers handle all of the messages. They have different topics, but in order to increase throughput, it supports you adding more than one broker to your system, right? And then you can also then have the topics be called like partition, meaning that it gets split across different brokers. So then it increases the throughput, right? If some brokers go away, all these kind of stuff, right? It happens and things happen. You also have more brokers behind the scenes to help. And Pulsar is all kind of like designed well to handle rebalancing all of these topics kind of thing. So Okay, so that's one thing. And I realize I'm kind of only have very little time, so I'm not going to go through some of these. If you are interested, look up the Apache book key if you're interested in that level of information. And I just want a quick summary. Apache Pulsar is a unified solution for PubSub. You can do PubSub. You can also do queuing and streaming and message mediation and enrichment through the function framework. And then queuing too, I wanted to point out how you can do it. Now, the other things are like it's cloud. You can do it on-prem, hybrid too. It's very flexible. It also supports this feature called geo-replication, multi-region support, and the list is growing. The fact is that the project is still going very hot. You know, there are lots of contributors. There are lots of also what they call the pips, right? Kind of like almost seems like JCP kind of Java community process. They have a pips kind of helps with community contributing ideas, and they're reviewing constantly. Kind of committee comes together and to decide, you know, what new features to do. Okay, so let me then really quickly go over, right? Key differentiator, it separates out the compute and storage, right? I already talked about it. Storage is handled by Apache Bookkeeper. And then the next thing is geo-replication. This has to do with your computer center. You are like, you know, having that, let's say in Europe, you got a huge center, you had in America and Latin America and Asia, and you need to replicate data. The nice thing about this is that you can actually replicate doing active pattern, active passive, which means you can keep running. It will do all the replication kind of behind the scenes kind of thing. And also too, it has selective message replication. So for example, you have Europe, you have GDPR data that's kind of privacy. You don't want it to leave the region. You can actually configure this replication process. So it has some of these convenience for you too. So it's kind of a nice feature to go along. And then multi-tenancy, as I mentioned, you can actually demarcate your data into different maybe functional areas. So it already has this feature too. And then this one too, I wanted to quickly go through. There's this from the message subscription side, there are different subscription mode. So if you use an exclusive mode, that turns it Pulsar into sort of like a message queue, because it becomes one-to-one versus like one-to-many. So you still have your broker, your producer produces messages to the topic, but you only have, you know, one consumer for that particular subscription. Is called exclusive. And then you can have failover subscription, which means you have multiple consumers. Only one is the primary. If the primary goes away, the secondary will take over. And then there's also shared too. And shared is allowing multiple consumers all subscribing to the same subscription. Very useful in a cloud native environment. And then if you need to guarantee your message ordering, you know, as you receive, you want to make sure it gets delivered in the order as it is received, you can use the key share too. Essentially, you have to then leverage on the key so then it knows how to order your messages too. So that's kind of a quick thing. Now, let me see. I think I might have only like 1 minute, but very fast, you know, a couple features, data pipelines, right? We have source, it travels through, you know, transformed by Pulsar, outputs data to a sink, kind of like that, a data pipeline. And essentially, you can use Pulsar function to help you with it. Very lightweight. I already talked about it. So currently, it's primarily Java, Python, and Go, but there will be more language support for it too. And then there's also this feature called Pulsar schema, because anytime you deal with asynchronous style of messages, you need to deal with serialization. It's deserialization, right? Flatten the object before it goes over the wire, come back, kind of build it up.